In this video, we're starting section 1.2 on arithmetic. Our goals are to simplify expressions using order of operations, PEMDAS, simplify fractional expressions, simplify expressions with absolute values, and to represent the absolute value with a piecewise function. So in this video, we will talk about order of operations. So let's get right into an example. So what is negative 3 squared? And part B, what is negative 3 in parentheses squared? So when we have stuff like this, we got to use order of operations. We got to use PEMDAS. So you'll likely have seen PEMDAS before. We have this acronym. And you know, the highest thing that you see, that's what you deal with first. And then you work your way down. So for example, with B, I see a parentheses and an exponent, but parentheses comes first. So I deal with that first. So, well, that just means that's a negative 3, and I'm kind of done with that. Now move on to the exponent. So I got to do negative 3 and then square that. So that means do negative 3 multiplied by itself. Negative times a negative is positive, so I get positive 9. Okay. If there's no parentheses like an A, well, I see a subtraction and I see an exponent, but exponent comes first in PEMDAS. So I would do 3 squared first, which is positive 9. So this means do 3 squared first, and then only after I do that, then stick the subtraction symbol in front. So I'd get 9, and then stick that subtraction in front, so minus 9. So we got to be careful with our order of operations. Okay, so let us do another example. Let's up the difficulty. So I got 3 of these that I want us to try. So I want to have you pause the video for a quick minute to try these. So pause the video in 3, 2, 1. Pause it and try these. You might not finish all of them in the minute, but that's okay. You're trying to make what progress you can. Okay, let's bring it back. Let's talk about these. So in A, I do see parentheses. I got to deal with the thing inside of that first. And within the parentheses, I see an exponent and a subtraction, but exponent happens first. So 3 squared becomes a 9. Then I put the subtraction in front of it. This whole thing, remember, is in the parentheses, and then there's that 5 times 10 plus 1. So I still got to do the thing inside the parentheses. That becomes a negative 4. So I got negative 4 times 10, and then plus 1. Well, what's parentheses negative 4? Well, that's just negative 4. So if I had wanted to, I could have just gotten rid of the parentheses at that point. Negative 4 times 10, and then plus 1. So multiplication comes before addition. So this gives me negative 40 plus 1. And then adding those, I'll get negative 39. All right. So for B, what changes is like where the exponent is. Now the exponent's outside of the parentheses. So, well, I still got the parentheses. I got to deal with that first. So 5 minus 3 is just 2. I got to do 2 and then square that times 10 plus 1. So, well, what's parentheses 2? Parentheses 2 is just 2. So I got to do 2 and then square that. Well, that's going to be 4. 4 times 10 plus 1. Multiplication happens before addition. So I'm going to do 2 steps in 1. 4 times 10, that's 40. And then add 1, and I'll get 41. All right, I'm going to trust that we can do those 2 at the same time. Okay, part C. So now there's no parentheses. So subtraction, multiplication, exponent, and addition. Well, exponent comes first. 10 squared, that's 100. Then multiplication comes before subtraction and addition. So multiplying that 100 times the negative 3, this part in the middle becomes minus and then 300. So now what I have is 5 minus 300 plus 1. So 5 minus 300 and then plus 1. So there's one, a bit of flexibility that we have here. All I have now is subtraction and addition. And technically, they're considered to be kind of at the same level. Similarly with multiplication and division. That technically means, I could do this in either way. I could deal with this subtraction first, or I could deal with this addition. I just have to be careful when I do it. So if I deal with the subtraction first, 5 minus 300 would be negative 295. And then add 1 to that, I'll get negative 294. So I could do it that way. Or if I wanted to keep the 5 as it is, I could deal with this addition, except I got to do negative 300. The negative's part of it. Negative 300 added to 1. So that's going to be minus 299. And now if I do the subtraction, I'll get negative 294. Okay, so same thing either way. Same thing either way. So I had some flexibility there. Do the subtraction first or the addition. But if I did the addition first, keep in mind that the minus is part of this 300. All right, so let's do another example. So are x plus y in parentheses squared and x squared plus y squared the same? Because it kind of seems like I should be able to distribute this squared to each of these, and if I did that, I would get this. So what I want you to do, I want to have you do a quick pause again for a minute. Try plugging in some values for x and y. And can you plug something in that makes these two things different? So pause it in 3, 2, 1, pause it. See if you can plug some values in. That might show that they're different. All right, so let's bring it back. Let's try it. So let's try plugging in x equals 1, and maybe I'll plug in y equals 2. And if I do that, this x plus y parentheses getting squared, well, that becomes 1 plus 2 in parentheses squared. And 3 squared, that's 9. Whereas the other one, if I do x squared plus y squared, I'm going to get 1 squared plus 2 squared. Doesn't really matter whether I put these parentheses or not, because parentheses 1 is just 1. That becomes 1 plus 4, which is 5. And these two things are clearly not equal. The 5 and the 9 are clearly not equal. And that shows that these two things are not necessarily the same, because they didn't end up being the same when I plugged these in. So a natural question we might have then is, well, how do I actually do this x plus y in parentheses squared? Well, when I square something, it means multiply it by itself. So this means do x plus y multiplied by another x plus y. And how do we work this out? Well, you might remember we gotta distribute this. We gotta FOIL it. So when you FOIL, you first multiply the first terms together, x times x, which is x squared. Then you multiply the outer terms, so x times y, that's just xy. Then I stands for inner, so inner terms, y times x, so plus yx. And then finally the L stands for last. Multiply the last terms together, and I get a plus y squared. Okay, and well, the two terms in the middle are actually exactly the same. So I got some like terms. This becomes x squared plus xy plus another xy. Well, that means I have two xy's plus y squared. All right, and there we have it. That's how we actually work it out if we needed to. Okay, all right, let's try another one of these. What about this problem? What about if I'm multiplying xy, then it's squared? Is that the same thing as x squared times y squared? So can I distribute the power here when I'm multiplying? So again, I want to have you do a quick pause for 1 minute. This time, don't plug in. See if you can do some algebra to this to show that they're the same. So pause it in 3, 2, 1, and try it. All right, so hopefully you paused it to try it. Let's talk about what I can do with this. So squaring this thing will mean multiply it by itself. So I'll get x times y times another x times y. And now I got x times y times x times y. When I'm multiplying a bunch of things together, I can do the multiplication in any order. So maybe let's multiply the x's together first. That'll give me x squared. And then times, now let's multiply the y's together, which will give me y squared. Oh, and that's x squared, y squared. It's the same as that. Okay, so these are the same. So the answer to this is yes, they are the same. And I'm realizing I forgot to write the answer to question 3. Were those the same? And the answer is no. And we showed that by plugging in some test values and got that they were different. Okay, so the general rule here is when you're adding or subtracting terms and there's a power, you can't distribute the power. Cannot. This is not equal to a to the p plus b to the p. Same for subtraction. Can't distribute the power to say it's a to the p minus b to the p. That does not work. We cannot distribute a power when adding or subtracting. But as we saw in this last example, if I'm multiplying terms and there's a power, distributing does work. Then I can say it's a to the p times b to the p. So distributing a power does work when you're multiplying terms or when you're dividing them.